Welcome to MRL. In this learning session, we'll be learning about quadrilaterals. Now, what is a quadrilateral? A quadrilateral is a polygon of four sides. A quadrilateral is a coplanar closed geometrical figure bounded by four line segments. A quadrilateral is a coplanar closed geometrical figure formed when four non-collinear points are joined in pairs by line segments which meet at their end points. So, this figure is a quadrilateral. Now, how to name a quadrilateral? A quadrilateral is named by taking the vertices in a particular order. Each vertex is denoted by a capital alphabet. Now, we have the four vertices here of a quadrilateral. We name the quadrilateral as A, B, C, D. We take the vertices in a particular order, and that is how we name a quadrilateral. Now, the conditions for a quadrilateral, for any figure to be a simple quadrilateral. In a quadrilateral, all the sides must be line segments. The sides should not cross, and the figure has only one interior. If you look at this figure, it has got only one interior, the sides are not crossing, and also the figure has what you call only line segments. Now, this is not a quadrilateral, nor this is a quadrilateral. Here the sides are crossing, and here one of the side is a curve, and therefore it is not a quadrilateral. Remember that. Now, the parts of a quadrilateral. A quadrilateral has four vertices, A, B, C, D. It has got four sides, A, B, B, C, C, D, D, A. It has four angles, angle A, angle B, angle C, angle D, and it has two diagonals, AC and BD. In all, a quadrilateral has 14 parts. 4 plus 4 plus 4 plus 2 is 14 parts. Remember that. A quadrilateral has 10 elements. That means leaving the vertices, 4 plus 4 plus 2 is 10. So, it has got 4 sides, 4 angles and 2 diagonals. They are the elements of a quadrilateral. The elements are required to construct a quadrilateral, and to construct a quadrilateral, a minimum of 5 elements are required. Remember that. Now, to understand the vertices, sides, angles and diagonals of a quadrilateral, let us discuss about the vertices first. A quadrilateral has 4 vertices. A quadrilateral has 4 vertices, and in that AB, the vertices A and B are adjacent vertices, BC are adjacent, CD are adjacent, and DA are adjacent vertices. In all, there are 4 pairs of adjacent vertices, and also A and C are non-adjacent and B and D are non-adjacent. Therefore, there are 2 pairs of non-adjacent vertices or 2 pairs of opposite vertices. Remember that. Now, if you talk about the sides of a quadrilateral has 4 pairs of adjacent sides. For example, here AB and BC are adjacent, BC and CD are adjacent, CD and D are adjacent. So, these are the 4 pairs of adjacent sides. Remember that. And also, in a quadrilateral, there are 2 pairs of opposite sides. AB and DC are opposite, BC and DA are opposite. There are 2 pairs of opposite sides. Again, about the angles in a quadrilateral, a quadrilateral has 4 interior angles, and in that angle A, angle B are adjacent, B and C are adjacent, angle C and angle D are adjacent, and D and A are adjacent. So, we have 4 pairs of adjacent angles, and also there are 2 pairs of opposite angles. A and C are opposite angles, B and D are opposite angles. Now, talking about the diagonals of a quadrilateral, we already know what is a diagonal. A diagonal is a line segment joining non-adjacent vertices of a polygon. Now, in a quadrilateral has only 4 sides, and it has got 2 pairs of opposite vertices, and therefore only 2 diagonals are possible in a quadrilateral. So, we have A and C are opposite vertices, B and D are opposite vertices or non-adjacent vertices. If we join AC and BD, we get 2 diagonals. So, therefore, AC and BD are the 2 diagonals in a quadrilateral. Please remember that. Now, angle sum property of a quadrilateral. We know that a quadrilateral has 4 interior angles, angle A, angle B, angle C and angle D, and the sum of these 4 angles, that is angle A plus angle B plus angle C plus angle D, or angle 1 plus angle 2 plus angle 3 plus angle 4, is 360 degrees. Now to understand this, let us do one thing. Let us join AC. Let us draw the diagonal AC. We divide, that means that divides the quadrilateral ABCD into two triangles. Now the sum of the angles of a triangle, that is triangle ACD, is 180, triangle ABC is 180, therefore 180 plus 180 becomes 360 degrees, and that is the reason why the sum of the four angles of a quadrilateral is 360 degrees. Please remember that. Now the sum of the interior angles of a polygon, we have the formula, that is n minus 2 into 180. Here n is 4, that means there are 4 sides, therefore 4 minus 2 into 180 is 2 into 180, therefore the sum of the interior angles of a quadrilateral is 360 degrees. Remember that. We also know that the sum of the exterior angles of any polygon is 360 degrees. A quadrilateral is a polygon, and therefore the sum of the exterior angles of a quadrilateral is 360 degrees. That is angle 5 plus angle 6 plus angle 7 plus angle 8, which are the four exterior angles of a quadrilateral. The sum is 360 degrees. Remember that. The next point of our discussion is what are concave and convex quadrilaterals. Now we already know what is a concave polygon and convex polygon. Let us understand here. A quadrilateral in which none of the interior angles is a reflex angle is called a convex quadrilateral. Also, in a convex quadrilateral, the diagonals are interior to the quadrilateral. If you see here, angle A, angle B, angle C, angle D, which are the interior angles here, none of them are reflex angles, and the diagonals, two diagonals of the quadrilateral are interior to the quadrilateral, and therefore it is a convex quadrilateral. Whereas in a concave quadrilateral, a quadrilateral in which one of the interior angles is a reflex angle is a concave quadrilateral, and also in a concave quadrilateral, the diagonal is exterior to the quadrilateral. If you look at the quadrilateral here, A, B, C, D is the quadrilateral, angle C is a reflex angle, and one of the diagonals BD is outside the quadrilateral or exterior to the quadrilateral. Therefore this quadrilateral is a concave quadrilateral. Please remember that. Now the next point of our discussion is regular and irregular quadrilaterals. Now what is a regular quadrilateral? A quadrilateral in which sides and the angles are equal is a regular quadrilateral. For example, here ABCD is a quadrilateral because there are four sides here, and the angles ABCD are equal, that is equal to 90 degrees, and the sides are also equal. Therefore it is an equiangular and equilateral quadrilateral, and that is a square. Therefore a square is a regular quadrilateral. Remember that. Now irregular quadrilateral, a quadrilateral in which the sides and the angles are unequal is an irregular quadrilateral. Now if you take a rectangle here, the four angles are 90 degrees, but in a rectangle the opposite sides are equal. That means all the sides are not equal, therefore it is an irregular quadrilateral. So also the rhombus, in rhombus all sides are equal, but the opposite angles are equal. That means all the angles are not equal, therefore it is an irregular quadrilateral. And also if you look at this quadrilateral ABCD, here none of the sides are equal or angles are equal still, and therefore it is an irregular quadrilateral. Remember that. The next point of our discussion is the types of quadrilaterals. The quadrilaterals are classified on the basis of pairs of parallel sides. There can be one pair of parallel sides or two pair of parallel sides. Now let us understand what do you mean by one pair of parallel sides. Now if you see here, there is AB is parallel to DC here, AB is parallel to DC. That means only one pair of parallel sides are there, one pair of opposite sides are parallel here, and if one pair of parallel sides exist in a quadrilateral, then that is called as a trapezium. And again in a trapezium we have got two types of trapeziums, that is isosceles trapezium and non-isosceles trapezium. In isosceles trapezium, not only the one pair of opposite sides are parallel, the non-parallel sides are equal. That is AB is parallel to DC and AD is equal to BC. In a non-isosceles trapezium, one pair of opposite sides are parallel and the non-parallel sides are unequal. That is AD is not equal to BC, and that is therefore in one pair in a quadrilateral, if one pair of parallel sides are equal, we have trapezium, which are two types, that is isosceles and non-isosceles trapezium. If there are two pairs of parallel sides, then we have a parallelogram or a kite. Now parallelogram has got the opposite sides parallel, and we have got the special parallelograms, that is rectangle, rhombus and square. In a rectangle, rectangle is a parallelogram in which one of the angles is 90 degrees, then a rhombus is a parallelogram in which one pair of adjacent sides are equal, and the square is also a parallelogram, or rather a parallelogram is a square if one pair of adjacent sides are equal and one of the interior angles is 90 degrees. When we talk about kite, the opposite sides are parallel here, but the opposite sides are not equal. The pairs of adjacent sides are equal, and that is the kite. So these are the examples of the quadrilaterals with two pairs of parallel sides. Remember that. Now we will be learning about the types of quadrilaterals in our next session, that is in the second part of quadrilaterals. Thank you.